Guys, in this video, let's talk about graph representation. So, okay, how do you represent a graph in programming, in C program specifically? Okay, how do you represent a graph in C programming, right? Okay, so to represent a graph, you can use two representations. So, representation of graphs. So, you can use adjacency matrix, something called as adjacency matrix, which is basically a 2D array, a two-dimensional array. And you can also use adjacency list. Adjacency list is also it's nothing but a linked list, okay? Linked list, which we have seen before in great detail, right? So let me explain this. Okay, how to represent a graph. Let me take a graph and let me show you how to represent this in C programming, right? So because you can't give graph as an input, right? How do you give this as an input? It's not possible. So there should be some way where you can represent this graph, okay? Where you can give this graph as input to the program, right? You can't give like this, okay? You may have complex connections, but you can't give a graph like this, okay? You have to convert this graph into some other representations. If you are intending to give this graph as an input to your program, then you have to convert this graph into some other representations. All right, so let me explain that. Okay, so yeah, so let me first explain how to store this graph in form of an adjacency matrix, okay, which is nothing but a 2D array, okay. A matrix contains rows and columns, right? You know that. So let me name the rows, okay. The row name should be the vertex or node name, okay. So there are 5 nodes here, 1 2 3 4 5. So I should be having 5 rows and 5 columns. Please remember this, okay. If you have 5 nodes in your graph, then you should be having 5 cross 5 matrix, which means 5 rows and 5 columns. All right. Yes. Now a to a, what is the value should be put here? What is the value should I put here? Okay. And a to a means you have to check whether a to a there is a connection. You have to check whether a to a there is a connection. From a to a there is no connection. You can see that from a to a there is no connection, right? There is no connection like that. We have not given any connection. So put 0. All right. And from a to b, is there any connection? Yes, it is. From a to b we have one connection here, one node, one link here, or one edge. So put 1. Okay, why you are putting 1? Because this is an unweighted graph, guys. I told you in unweighted graphs the weights are by default it is 1. If we have mentioned any weight means, then you have to put that weight only, right? 5. Okay, but fortunately there are no weights here, so we can very well put 1. Okay, let's take 1, right? From B to C, again there is a connection, so sorry, from I have to check whether from A to C. From A to C I don't have any direct connection, so 0. From A to D, yeah, I have one connection, so 1. From A to D I have one connection, guys. And from A to E I don't have any connection, so 0, right? I only have to check for an adjacent connection. Okay, adjacent means the direct connection, okay. Adjacent connection or adjacent edge, okay. Direct connection, okay. Of course from A to C you can go to B. From A then you can reach C, but that is not a direct connection, okay. That is not an adjacent connection, okay. That is not an adjacent connection. Adjacent connection is the immediate connection between 2 nodes, okay. The only connection between 2 nodes. In between that connection you should not have any other nodes. So from A to B there is a direct connection, and from A to D there is a direct connection. So I have put 1 1 there. And when I talk about B, from B to C I have one connection. So from B to C I have one connection, and from B to D I have another connection. From B to D, right? So from B to D I have another connection. That's it for B, right? And everything else is 0. Okay. And if I consider C, I don't have any connection from C, I hope. No, I don't have anything. So from C, uh, I should put all 0 because I don't have any connection from. You can see all are marching towards C, but there is no connection away from C. So put C, put C all zeros in C. From D, yeah, I have one connection to E. Here I can see I have one connection to E. So from D to E, I have one connection. Rest of all are 0. From E, yeah, I have one connection to C. So from E to C, I have one connection. Rest of all 0. Right? Okay. So this is called directed graph, guys. This is unweighted directed graph. Okay. Because you have direction, so you easily put the adjacency. This is your adjacency matrix, and you have to give this as your input. Okay. For this particular example, right? And let me take an undirected graph also. Okay. Let me take the same example and let me not put any direction. Okay. A to B to C D E, right. So there are no directions here. Now how will you represent the adjacency matrix? It goes the same way, but you have some extra information here. Let me tell you why. Okay, super. And from A to B there is a connection, so put 1. And from A to D there is a connection, put 1. Everything else is 0, right? From B there are 3 connections, guys. Since they are unweighted, you can see B there are 3 connections, so you have to mention all the connections. Okay, from B to D there is 1, from B to E there is 1, and from B to C there is 1, from B to A again there is 1. All right, so you can see there are 4 connections in B. Since they are undirected, you should have 1 in all the cases. Okay, because if they are undirected means what do you mean by undirected? From A also you can reach B, from B also you can reach A. So you should have 1 in both the cases. You should have 1 in both the cases. What I mean is, from A to B also you should have 1, from B to A also you should have 1. Okay, whereas in the directed you can check from A to B only we have 1, from B to A we don't have 1 because that is directed. Okay, undirected means in both the cases you should have 1, right? Yeah, I think you can fill C, D, E. That goes the same way. Okay, let me fill it. C, from C to B, C to E, that is 1. Okay, C to B and C to E, rest of all 0. D, if I consider A and D, so A and E for D, okay, rest of all 0. E, if I consider B, D, C, okay, you can see that here B, D, C, okay, so D, B, C. So E, if I consider it is D, B, C, or rest of all 0. That's how you should write an adjacency matrix. Okay, adjacency list, it's again very simple, guys. Adjacency list. Okay, let me take an example. A, B, C, D, right? This can be represented as a single list. How from A you can have a starting node, and you know that linked list which will contain a single node, and node will contain 2 information, right? One is the data and another one is the next, which means the address of the next node, right? Address of the next node, so that will link the node, right? So from A node you have address to B, and from B you have address to C, and from C you have address to D, and null in the okay, so from D also you are having address to A, right? You can connect like this circular linked list, or you can say that is null. And yeah, that's how you can represent this graph as a adjacency list. All right, it is not necessary to go with one list. You can even go with two or more lists. Okay, let me tell you how. So A, B, C, D. Let me take the graphs, and you can mention the nodes as external pointers. Okay, you can mention the nodes as external pointers. What is the external pointer that we have discussed in linked list? That is start, right? the start, the reference node. You can even mention A, B, C, D as external pointers. Doesn't matter, right? Let me have directions. Super. Okay. And A points to B, right? A points to B. So A points to B node, node B. This is just a pointer, whereas this is a node. Okay, node B. And from B points to, yes, I could stop here. Node B, and B points to node C. C points to node D, and D points to node A. I can also represent like this. Okay, this is also a correct representation. I can even have a lot of representations like linked list, but we actually use this adjacency matrix a lot. Okay, I hope you understood the representation of uh, graphs using linked list and matrices. Yeah, thanks a lot.